Okay, Assalamualaikum. Today we'll be talking about how a BJT works. This is the second take. Last time I didn't record the voice. So now BJT, how a BJT works. Okay, so now basically, so we know the BJT has three terminals, which is the emitter, the base, and the collector. Now, okay. So, and we also know, let's say this N channel, NPN, NPN, what do you call it? BJT. So this over here is like a PN junction back to back like this, right? So let's learn how the BJT works in a forward active mode, which means the base to emitter junction we forward bias, and the base to collector junction we reverse bias. So we forward biasing this junction and we reverse biasing this junction. So when we forward bias a junction, it means there will be a lot of current flow, and the current flow is due to diffusion. So here we see a lot of in the N side we have a lot of majority carriers are the electrons. So so electrons over here will diffuse to the base region. So electron from the emitter will diffuse to the base. And when majority of electron enter a p region, right? So free electron means free hole. So you will have recombination happening inside the base, but not many, because normally you will try to make this region over here, the base region here, to be as small as possible to reduce the probability of the electrons recombining with the hole. Now, so some will recombine, and most of it will drift. Most of the electron will drift to the collector. So this is diffusion. This will drift to the collector and be collected. So since the direction of the electron are like this, so the current is always the opposite direction of the flow of electron. So the current will be the opposite direction over here. So this is IC. So also since here the electron are flowing from here to here, so the direction of the current here will be the opposite direction, which is over here. So IE. And then the base, how about the base current? The base current here, since the electron will combine with the hole over here, the hole inside the base will be replaced by the hole coming from the outside circuit. So if that's the case, so the direction of the hole will be like this, right? And therefore the direction of the current is the same as the direction of the hole. So this is the base current. So if you look at here, then you learn from your first year that IE equals to IC plus IB. So the total that current that being generated over here is a sum of the collector current and the base current. That's number one. And number two, we learn about the gain. Gain is IC over IB. This, as we know, the gain. So if you want the gain to be as big as possible, right, we want to this IC, the gain to be big, so we will make IC to be as large, and then we try to reduce the IB. So how do we reduce IB? How do we reduce the how do we reduce the base current over here? Is by reducing recombination. So how do we reduce the recombination? Is, again, as I mentioned before, one of the way is to reduce the area of the base, so the probability for it recombining is less. Another thing, we try to also reduce the doping of the P. So if you reduce the P doping over here, the number of holes will be less, therefore recombination, the probability for recombination to happen also less. So that's how a BJT works.